So I'm going to complete the Module 8 test review in preparation for the Module 8 test. So question 1, we want to convert the rectangular point 3, 7 into polar coordinates. So if you remember, the way we convert to polar coordinates is we use r squared equals x squared plus y squared to get our distance r, and we use that theta equals the tangent inverse of the absolute value of y over x to find our theta. So plugging in x and y, we end up with r squared equals 3 squared plus y plus 7 squared, which becomes 9 plus 49. So r squared equals 58. Taking the square root, we get that r equals the square root of 58. Solving for theta, we get theta equals the tangent inverse of the absolute value of 7/3. Now the absolute value of 7/3 is just 7/3, so the tangent inverse of 7/3 gives us that theta equals 66.8 degrees. And because our rectangular point is in quadrant 1, our polar coordinate is as well, so our reference angle of 66.8 degrees is our theta for our point. So our polar coordinate is the square root of 58, 66.8 degrees. Next, we want to convert the polar point -5, 15 degrees into rectangular coordinates. So to find rectangular coordinates, we use x equals r cosine theta and y equals r sine theta. Plug in r and theta, we get x equals -5 times the cosine of 15 degrees. Now 15 degrees is not on the unit circle, so we can just use a calculator to evaluate. And -5 times the cosine of 15 is going to give us -4.83 for x. For y, we get -5 times sine of 15 degrees. And again, using a calculator, we get y is approximately -1.29. And when you graph the polar point, you do end up in quadrant 3 because we travel a positive 15 degrees, then we go in the opposite direction, a distance of 5. So -4.83, -1.29 in the third quadrant is our rectangular point. Now we want to convert r equals 3 cosine theta into an equation in rectangular coordinates using x and y. So using that x equals r cosine theta, we're going to end up with r equals 3 times x over r. So if I solve that equation for cosine, you get x over r. So we get r equals 3x over r. Multiply both sides by r. We get r squared equals 3x. Again, using the fact that r squared equals x squared plus y squared, we get x squared plus y squared equals 3x. Subtract 3x from both sides, and we end up with the equation x squared plus y squared minus 3x equals 0. So this is the equation in rectangular form. And just an extra piece of information, this is a circle when graphed. Next, we want to plot the equation r equals 3 plus 4 cosine theta by plotting points. And it's always a good idea to pick out what the equation is going to look like when graphed first. So if you look back in your section 5 notes, anytime you have a number plus cosine of theta, it's going to be a lemma. And this is going to be with a loop. So that's going to help me once I pick my values for theta and plot my points. That gives me an idea of what my graph has to look like. And you can also use Desmos to graph it to double check that your values are correct and you end up with the correct shape. So I'm going to start off by picking the value 0 for theta, which is going to give me a value of 7 for r, and I'm not going to show my work here. You guys can use a calculator to evaluate for each of these values of theta or work them out on your own. Next, I'm going to choose the value pi over 3, which is going to give out 5 for r. Next, I'm going to choose pi over 2, which is going to get a value of 3. Then I'm going to choose 2 pi over 3 for theta, which is going to give out a value of 1. Next, I'm going to plug in pi, which will give out a value of -1. Then 4 pi over 3, which is going to be 1. Then 3 pi over 2, which is going to give out a value of 3. And just so that we start at the same place we started, sorry, one more, not that value. Last value I'm going to plug in is going to be 5 pi over 3, which is going to give us a value of 5. So now I'm going to plot all of our points. So starting with the point 70, we don't quite have enough space to have the point 70, so it's going to be a little bit outside our graph. Then we have the point 5 pi over 3. Pi over 3 is at the top here. It's going to be the last circle. Then we have pi over 2, and then we have 3 pi over 2. Then we have 2 pi over 3. At pi, we have -1. So remember, even though pi is on the left here, traveling a distance of -1 is going to give us on the positive side of our axis. Then 4 pi over 3 is going to have a value of 1. Then 3 pi over 2 has a value of 3. And then lastly, 5 pi over 3 has a value of 5. So remember, we need to have a loop when we graph this. So when I come in to do my loop, I'm going to pass through 1, and that's where my loop is going to occur. Then I'm going to go back out and continue my graph. And when graphed in Desmos, this is going to be the graph we get for r equals 3 plus 4 cosine theta. So the last problem, problem 5, has to do with vectors, and we're going to use the vector a equals 3i minus 4j and b equals -2i plus 5j for all of our problems. So the first thing I want to do is rewrite both vectors in component form. So a is going to be 3, 4, and b is going to be -2, 5. It's going to be easier to work with our vectors in component form. So the first thing we want to do is find a plus b. So when you add two vectors, so if I do 3, 4 plus -2, 5, you add your x values and then you add the corresponding y values. So that's going to give us 3 plus -2 and then -4 plus 5. So the sum of our two vectors is going to be 1, 1. Next, we want to know what the magnitude of our sum is. So remember, these double bars represent magnitude. So remember, the magnitude is found by doing the square root of the sum of the squares of our x and y values. So in this case, it's going to be the square root of 1 squared plus 1 squared, which becomes the square root of 1 plus 1. So the magnitude of a plus b equals the square root of 2. Next, we want to know the direction of our sum, direction of a plus b. So remember, direction is an angle measure. It is not north, south, east, or west, or a combination of those. It is an angle measure. So we find that angle measure. So theta equals the tangent inverse of b over a. And in this case, b and a represent the x and y values of our vector. So that's going to become the tangent inverse of 1 over 1. So theta equals pi over 4 radians, or if you're going to write it in degrees, it equals 45 degrees. Next, we want to know what negative 4a minus 7b is. So remember from the notes, typically we rewrite the subtraction of two vectors as the addition of a negative. So I'm going to write this as negative 4a plus negative 7b. So I'm going to find negative 4a first. So scalar multiplication, you multiply each value of your vector by the scalar. So that means 3 times negative 4, and then negative 4 times negative 4, which is going to give us the vector negative 12, 16. And then negative 7b, we're going to take our vector b, so negative 2 times negative 7, and then we're going to have 5 times negative 7, which is going to give us the vector 14, negative 35. So now when we add our vectors, negative 4a plus negative 7b, we're going to do negative 12 plus 14, and then 16 plus negative 35. So we end up with the vector 2, negative 19. Lastly, we want to know the angle between the two vectors. So using our notes, we have the formula cosine theta equals a dot b over magnitude of a times the magnitude of b. We do not have any of these values. We don't have the dot product of our vectors or the magnitude of each one individually. So we need to find those values first. So when we do dot product, we multiply the x's, and we multiply the y's, and we add them together. So that's going to be 3 times negative 2 plus negative 4 times 5. It's going to be negative 6 plus a negative 20. So our dot product is going to be negative 26. Next, we want to find the magnitude of vector a. So the square root of 3 squared plus negative 4 squared, which is going to become the square root of 9 plus 16, which is the square root of 25, which equals 5. And then lastly, the magnitude of vector b, which is going to be the square root of negative 2 squared plus 5 squared, which ends up being the square root of 4 plus 25. So we end up with the square root of 29. Now that we have all of the necessary information, we can go plug it into our equation. So we end up with cosine of theta equals negative 26 divided by 5 times radical 29. Taking the cosine inverse of both sides, we get that theta equals the cosine inverse of negative 26 over 5 radical 29. And then it just becomes plugging it into a calculator. So we get that theta equals 164.93 degrees. So the angle between our two vectors is 164.93 degrees.